Now we'll talk about parallelogram. What is a parallelogram? A parallelogram is a quadrilateral which has two pairs of parallel side. This side and this side is parallel to each other, and this side and this side, they are parallel to each other. Now the opposite sides are also equal to each other. Now what is an area of a parallelogram? The formula for the area of parallelogram is base into height. Area of, I'll denote parallelogram by two parallel lines and GM. This will be parallelogram. So area of parallelogram would be base into height. Now you might wonder, why is the area of a parallelogram equal to base into height? For example, let's say I'll draw a rectangle. The height of this rectangle is h and the base is b. Suppose I push the rectangle from this edge. I apply some force on this rectangle, keeping the base fixed. Keeping the base fixed, if I apply some force, this rectangle will become somewhat like this. The base is fixed, but the edges, they have moved. And this dotted length would be h. Now, as you have changed the orientation of the rectangle, but the area would remain same. For a rectangle, the area is length into breadth, that is height into base. Similarly, for a parallelogram, the area would be height into base, because it's the orientation that has changed, but not the area. The area still remains the same because we have not added anything or we have not removed anything. We have just changed the orientation. Let's do some questions on parallelogram. In this question, we are given a triangle and a parallelogram. They have the same base. We are given that the parallelogram and the triangle, they have same area. So let's say this is a triangle and this is a parallelogram. A parallelogram is A, B, C, D, and a triangle is AEB. They both have the same area, and the sides of the triangle are given as 26, 28 and 30. But the parallelogram stands on the base 28. So the common side is 28. This side is 28 centimeter, common between the triangle and the parallelogram. The other two sides are, this is let's say 26 and this is let's say 30 centimeter. Now what we need to do is we have to find the height of the parallelogram. We have to find this perpendicular height of the parallelogram. We are given all the three sides of the triangle. By using the three sides, we can calculate the area of the triangle. And as it is given in the question, the area of the triangle and parallelogram are equal. And area of parallelogram can be known, and area of parallelogram is equal to base into height. Base which is known, so height can be calculated. Let's see how to proceed with this question. First we'll calculate the area of the triangle AEB. Triangle AEB, the perimeter is sum of all the three sides, that is 26 plus 30 plus 28, which makes it 56 plus 28, that is 84 centimeter. The units are in centimeter, okay, 84 centimeter. So the semi perimeter would be half of 84, that is 42 centimeter. Half of 84 is 42 centimeter. So let's calculate S minus A. S minus A would be 42 minus 26, which is nothing but 16 centimeter. S minus B would be 42 minus 30, which is 12 centimeter. S minus C would be 42 minus 28, which is 14 centimeter. So we've got the values of S, S minus A, S minus B and S minus C. Now let's calculate the area of the triangle. By Heron's formula, area of the triangle is S into S minus A into S minus B into S minus C. Substituting the values, S is 42 centimeter, S minus A is 16, S minus B is 12, and S minus C is 14. Now to multiply this, it is a very difficult task, and as we have already studied, we'll employ another technique. We can write 42. 42 we can write as, let's say first we'll write 14 as 7 into 2. We'll write 12 as 2 into 6. We'll write 16 as 2 into 8. And we'll write 42 as 2 into 21. So we got too many 2's in this. So this becomes 1, 2, 3, 4. 2 to the power 4 into. Now 21 can be written as 7 into 3. So the 7 from here and this 7 makes it 7 square. And 3 from 21 into 8. 8 can be written as 4 into 2. And 6 can be written as 2 into 3. So this becomes, this 3 and this 3 can be clubbed together to make 3 square. I am rubbing this 3. This 2 and this 2 can be clubbed to make 2 to the power 2. That is 4. So I am rubbing these and making it as 4 square. So taking these numbers out of the radical sign, I get 2 to the power 2 into 7 into 3 into 4. 2 to the power 4 is 2 is 4. 4 into 4 16. 7 into 3 21. So 21 into 16, which is 336. So final answer is 336 centimeter square. This is the area of a triangle. This is the area of the triangle. Now we know that area of the triangle and area of the parallelogram both are equal. Area of triangle is equal to area of parallelogram. This is given to us. So area of parallelogram would be 336 centimeter square. Now the formula for area of parallelogram is base into height is 336 centimeter square. Now the base of the parallelogram is 28. So 28 into h is 336. So h becomes 336 by 28, which is nothing but 12 centimeter. So height of the parallelogram comes out to be 12 centimeter. So let's move on to another question. First we'll talk about rhombus. Now what is a rhombus? Rhombus is also a kind of parallelogram, but there is a special property about rhombus that all of the sides of a rhombus are equal, and the diagonals of a rhombus, they bisect at 90 degrees. Let's see. Suppose I'll draw a rhombus. In a rhombus, all the sides are equal. So AB is BC, is CD, is BD. BC is not there. AB is BD. I'll number them again. A, B, C, D. So the sides AB is BC is equal to CD is equal to AD. All the sides are equal, and when I draw the diagonals, the diagonals they intersect each other at 90 degree. So the area of a rhombus, the formula says the area is, if the length of one diagonal is say D1 and the length of another diagonal is say D2, the area of the rhombus is half into D1 into D2. Now how come the area of the rhombus is half into D1 into D2? Let's say we can divide the rhombus into 4 triangles. Let's call this point as O. The 4 triangles are AOD, AOB, BOC and COD. All the 4 triangles are right angled triangle, and all the 4 are right angled at O. So the area of any triangle would be half into base into height. Let's say consider this triangle AOD. The base would be, base is this much, which is nothing but half of the diagonal D2. So it will be D2 by 2, and H is AO. O is nothing but half of the diagonal D1. D1 by 2. So this becomes half into D1 D2 by 4. So area of this triangle AOD is half into D1 D2 by 4. So if I have to calculate area of all the 4 triangles, I am naming them here, all the 4 triangles, I have to multiply by 4 to get the area of the rhombus. So this becomes area of rhombus is 4 times area of the triangle. So this 4 and this 4 cancels out, and we get half into D1 into D2. So here we have proved that area of a rhombus is half into the product of the diagonals. Now let's do one question on this concept. Now here we have been given a rhombus. The sides of the rhombus are given. The side is 100 meter. So all the sides become 100 meter. Sanya, she has a piece of land which is in the shape of a rhombus. Now what she wants is, she wants to divide the land between her daughter and her son to produce 2 different crops. The son would be growing the crop in this part of the area, and the daughter would be growing the crop in this area. So what we need to do is, we have to calculate the area of crop for both the son and the daughter. Now since it is a rhombus and the diagonal divides the rhombus into 2 triangles of equal areas, we have to calculate the area of any one triangle, and then we'll get the area for both the daughter and the son as well. Now let's draw the rhombus. The sides of the rhombus are all equal and equal to 100 meters, and the diagonal is 160 meters. Now let's name the rhombus A, B, C, D. Now to calculate the area of the rhombus, we will first calculate the area of triangle ABD. Area of triangle ABD. The perimeter of the triangle ABD would be the sum of all the 3 sides, that is 100 plus 100 plus 160, which makes it 360 meters, as the dimension is in meters. Now the semi-perimeter S would be half of the perimeter, that is half into 360, which is 180 meters. We have calculated S. Now what we need to do is calculate S minus A, S minus B and S minus C. S minus A would be 180 minus 100, which is 80 meters. S minus B would be 180 minus again 100 equals 80 meters, and S minus C would be 180 minus 160, that is 20 meters. So now we have calculated the values of S minus A, that is 80 meters, S minus B 80 and S minus C 20, and the value of S. Now what we need to do is just use the formula for area. The formula for area is root over S into S minus A into S minus B into S minus C. Now putting the values of the quantities, S is 180, S minus A is 80, S minus B is again 80 and S minus C is 20. Now as we can see that this is a big multiplication problem, so we will try to break it into simple problems. We can write 80 as 2 into 90. We can write this 80 as 2 into 40, this as 2 into 40, and this will remain 20. Now 40 can further be broken into 2 into 20. So let's write 2 into 20 this 40 is broken into 2 into 20. So how many 20s do we have? 1, 2 and 3. So we have 3 20s. So I'll write down 20 cube. Now what other values do we have? We have 1, 2, second, third, fourth and fifth. We have 2 to the power 5. And what is remaining? Remaining is 90. So let's take the values after the outside the radical sign. 20 cube will become 20, 2 to the power will become 4, and what will remain inside would be 20 into 2 into 90. So this will become 80 root over 3600. So 3600 under root is nothing but 60. So this is 80 into 60, that is 4800 meter square. So the area of the triangle is 4800 meter square. Similarly, as area of second triangle BCD would be 4800 meter square, because a rhombus when divided by a diagonal divides the triangle into two triangles of equal area.